Have you ever cranked up your favorite song, ready to get lost in it, only to have the whole thing turn into this awful, buzzing, distorted mess? Yeah, it's super frustrating. But that sound, it isn't just about volume. It's actually about these hidden spikes of power that your gear just can't handle. So today, we're going to pull back the curtain on this whole thing by diving into something called Crest Factor.
Visit youtube.com/avidsystem and don't forget to subscribe.
All right, first things first, let's talk about that sound, that all too familiar buzz that can absolutely ruin a great music moment.
I mean, we've all been there, right? You turn the knob up, expecting it to get bigger and better, and instead the sound just gets, well, fuzzy and harsh. What is actually happening in that moment when your speakers just seem to give up?
Now, you might think the problem is simply that it's too loud, but the real culprit is something a lot more sneaky. Your speakers aren't really struggling with the average volume. Nope, it's the sudden, invisible spikes in the signal that are causing all the chaos.
So to really get our heads around this, we need to look at how these signals are even measured. Turns out, there's more than one way to think about loudness.
You see, every audio signal has two really key values. The first is its RMS, or root mean square value. The easiest way to think about this is as the average power. It's like the steady average level of the sea. But then you've got the peak value. This is the absolute highest point that wave reaches. Think of it like a sudden giant rogue wave just towering over the rest of the ocean. Most of the time we're only paying attention to that average sea level, but it's the peak, that rogue wave, that causes all the trouble.
So, how do we actually measure the difference between that calm, average sea level and that massive rogue wave? Well, that's our key concept for today comes in, defining the Crest Factor.
Crest factor, which you might also hear called the peak-to-average ratio, or PAR, is really just a simple measurement. It tells us exactly how extreme those peaks are compared to the average. It's basically a number that quantifies the spikiness of a signal.
And the math behind it? It's beautifully simple. You just take that peak value and divide it by the RMS value. That's it. A low number means the peaks aren't that much higher than the average. But a high number, well, that tells you you've got some seriously extreme, spiky peaks hiding in there. Now, here's where it gets really interesting. Not all signals are created equal, not by a long shot. The Crest factor can be wildly different depending on what kind of waveform we're looking at, as you're about to see in this lineup. Okay, let's check this out. A perfect clean square wave has a Crest factor of exactly 1. Its peak is its average. It's totally flat. A smooth sine wave is a little bit spikier at about 1.4. A triangle wave, which is sharper still, comes in around 1.7. But then you look at music, or even just the human voice. The Crest factor can be 4, 10, or even higher. What that means is the peaks in your favorite song can demand 10 times more power to reproduce cleanly than the average level you're hearing. 10 times!
So music has these crazy peaks that can be 10 times higher than its average. Why in the world does that matter? Well, this number, this concept, is the exact reason your speakers start to buzz and distort.
This right here is the absolute key. Your amplifier, the engine that drives your speakers, it doesn't really care about the average power. It has to be able to handle the single highest peak that gets thrown at it. If it doesn't have enough power in reserve, what engineers call headroom, to handle that musical rogue wave, it runs into big trouble.
So here's the play-by-play of what happens. That high Crest factor signal from your music slams into the amplifier. Those huge peaks demand way more power than the amp can possibly supply. So the amp does the only thing it can do. It literally clips the top of the wave right off, flattening it out. That newly clipped, squared-off wave is a distorted signal, and that's what creates that harsh, nasty buzzing sound you hear. And you know, this whole idea isn't just about getting clean audio from your stereo. Understanding Crest factor is actually critical for safety and accuracy in electronics all around us.
Yeah, this concept has some pretty serious real-world consequences. For starters, power quality. A lot of modern electronics draw power in these short, spiky bursts, which creates high Crest factor currents that can literally overheat the wiring inside your walls. Then there's component safety. Fuses and circuit breakers have to be rated to handle these insane peaks, not just the average current they see. And finally, accurate measurement. Technicians need a special tool called a true RMS multimeter just to get an accurate reading on these spiky loads. A standard meter would give them a dangerously low reading, which is not good.
So, let's wrap this all up. What do you need to remember? First, Crest factor is that crucial ratio of a signal's hidden peaks to its average power. Second,
Dynamic things like music are incredibly spiky and need way more power than you'd probably guess. And finally, ignoring crest factor is exactly what leads to that awful distortion, and it can even be a real safety issue for your electronics and your home's wiring.
So, the next time you hear a buzzing speaker, you'll know exactly what's going on. It's not just loud, it's a signal with peaks that are way too high for the system to handle. And this leaves us with a final thought. We've just seen the danger of judging an electrical signal just by its average. So, where else in life might we be missing the whole picture by only looking at the average and ignoring the peaks? It really makes you think, doesn't it? Thanks for joining me.
Thanks for watching.